Hello everyone. Today in this video I will explain and demonstrate in details my machine learning federation project, which is machine learning lifecycle management with MLflow based on real example, which is used car price prediction. But before going in details, let me give you a simple overview about machine learning lifecycle and MLflow. So machine learning lifecycle is defined as a cyclical process that involves four steps. So we find raw data, data preparation, data modeling and training, and model deployment. But manage and monitor this life cycle in production is a difficult task. So to optimize this process, there are many machine learning lifecycle management platforms that help us to do this work. And below this platform, we find MLflow. So in simple words, MLflow is an open source platform for managing the end-to-end machine learning lifecycle. It allows us to track hundreds of model environment, dataset, model parameter, and even hyperparameter, and reproduce them when needed. So MLflow contains four components. We find MLflow tracking to record the model performance over the time. So you can, for example, save your code, your data, and even your results. We find also MLflow project. So this component is responsible for package the code in format to reproduce run on any platform. The third component is MLflow models. So with this component, you can deploy machine learning models in diverse serving environment. And the last one is MLflow repository. This component is responsible for storing the model in a central repository. As I said in the beginning, my project is used car price prediction. So the first step is recuperating the dataset from Kaggle. So this is the dataset from Kaggle, and then do some data preprocessing before going to managing the life cycle using MLflow. So the first step is import all the package required. Then I imported the data frame using pandas. Do some data exploratory. So this data frame contain 8,128 rows and 13 columns. So this is overview about columns. So we have the name of the car, the year, the selling price, which is the target column. We have the kilometer driven, the fuel type, the transmission, the owner. After that, I display the type of each column. Then do some statistics like the mean, the standard deviation, the max of each column. After that, I display the null value. So we have for the column mileage, engine, max power, and torque and seat. We have the null value. So this null value will be handled in the next step, which is data preparation. Do some plot, for example, for the fuel column, we have the most presented fuel type, which is diesel and petrol. For the owner, we have the first and the second owner present the most presented type in the dataset. And now let's move to the data preprocessing and data cleaning. So the first step I do it is drop the torque and the seller type column. Then I extract for example, for the name, I just need the first word. So I use the function split by space and just take the first word. Even for the column mileage, we need just the numbers, so we don't need this unit. After that, for the null value, I choose the method mean. That's mean that all the column that present the null value will replace it by the mean of this column. And after doing the function fill now, all the null value are replaced with the mean, and so we don't have null value. For the column name, for example, if we check this graph, we find that many cars that present under 15. So the idea here is grouped all the cars that present count value under 15, replacing them by the name up. So for the kilometer driven, we find some outliers that we will handle it in the next step, which is remove outliers. As I said, in the column kilometer driven, we have these two outliers. So the idea here is to remove all the outliers presented in the column kilometer driven by using the famous method, which is percentile. And after running this function, we find that all the data, the outliers in kilometer driven, are removed. Same for the selling price. We apply the function percentile. On years, we find that all the data presented before 205 is considered as outliers. So the idea here is to remove all the data, all the rows that have the column years before 205. And the final step is display the correlation matrix to know what exactly the column that have a correlated a higher correlation with the column selling price, and consider this column as the model features. So as we see in this correlation matrix, we find that for example, seats and mileage have the low correlation with the selling price. So we can remove these two columns. And finally, save the cleaning the data frame in the CSV file to use it directly in the next step without needing to execute this pre-processing each time. Now let's move to the MLflow part. But as I said in the introduction, we will use the MLflow tracking to save all our experiments. So the first step before going to the MLflow is define the MLflow tracking server using this command. So MLflow serve minus backend store URI. So we defined database SQLite named MLflow to store all the tracking experiments, and define the MLflow runs as default artifacts root. So this folder will store all the file generated on each run. And of course, we define the host, which is localhost, and execute this command. So as I see, the server tracking is created with the localhost and the port 500. So now we can begin the MLflow parts. So the first step is import the MLflow libraries, which is MLflow and MLflow tracking. Second, set the server URI. So here we need to set the tracking URI, the server that we already created, which is localhost and the port 500. Also create a new experiments. So which is I name it here, for example, use it car price prediction, and set these experiments to be the default experiments. So after that, I load the data frame that already saved in the the previous step, which is data cleaning and preprocessing, do some label encoder and one hot encoder for the categorical colon. After that, specifying the feature and the target of our model. So the target is the selling price. After that, divide the data into training and test part, and now we can start the ML flow tracking. So the used car price prediction is a regression problem. For this reason, I choose just to model a regression, which is linear regression and random forest regress. So for the linear regression, I choose, for example, the parameter normalize, specifying to true. I start the run with the name linear regression run 1, and I start fitting the model. After that, I specifying the evaluation matrix is mean squared error, mean absolute error, and error to score. Then, using MLflow, I save the model. I save the parameter using log param keyword. After that, I save the metrics using log metric, and the final step is save the model using MLflow scikit-learn log model, and pass the model as parameter. So after running this code, a folder will generate it automatically. Let's check this folder. So for example, this folder will created with the run ID, and will contain all these files. So we have conda.yaml that contain all for example, contain the language, which is Python, contains the package, which is MLflow and scikit-learn, and contains the conda environment. Also, we have ML models and the requirement. This requirement contains all the required packages to run this model. Let's return to the MLflow part. So after that, we just change the normalize the parameter of the linear regression with false, and execute this code. For the random forest, it's the same process, just specifying the parameter of the random forest regressor, and also specifying another parameter, and re-execute this code. So each time the MLflow tracking will save the parameter, the matrix, and the model. After completing the tracking part, we can go to the browser and exactly for the tracking server. So in our experiments, we find all the runs presented here. And this is another feature for MLflow. So using a user interface, you can compare all the runs. You can save your models. For example, you can transact your model from for example, for the staging to production, or for the production to archive. Now it's time to compare all the runs and detect which is the model that have the higher score, and save this model. So you can compare the model in this user interface. For example, you can select the linear regression run, click on compare, and you compare your model using, for example, the matrix mean absolute error, the error score matrix, and the mean square error. Or you can compare all the runs using code. So let's return to our code. For example, search all the run with the experiment ID 1, which is our experiment. Sort all the runs based on the matrix R2, and using ascending false to sort them in in ascending order, and take the first one. So the first ID, run ID here, is present the run ID that have the higher score. then create a new model. For example, I named this model user car price prediction, and save the model that presented in the MLflow folder, the run ID, the experiment ID one, the run ID, which is the best run ID. Save this model in the MLflow model. So after executing this command, you can see that the model created is car price prediction with the version 1. So if we need to check the creation of the model using the user interface, you can return to the user interface and click here on the model. So we find that the model is created and with the version 1. After that, you can transit the model from, for example, the none, which is the default stage, to the staging using this command. So you can specify the model name, the version, and the stage. For example, here staging to transit the model from the none to staging. Even you can transit the model from the staging to production using the same command, just change the stage here to production. And now while the model is is saved and in the production stage, let's make some predictions. So we defined a function. I defined the function that take all the features from the user and transform there to the data frame, which will be the input data to the model to the prediction. After that, I specify the model name, which is used car price prediction, and the stage, which is production. So I load the model from models using these two parameters, and then predict the data frame returned by the function. So for example, when I choose the car name OD, the transmission is manual, the fuel is petrol, the owner is one, the year is 2011. For example, the kilometer driven is 1500s. The max power is, for example, 2015, and the engine is 150. I get this result. The same here, just with another features. Now, since our model is created and in the production stage, so we can serve it using MLflow serve to the final user. So all we have to do here is to run this command MLflow model serve and specify which is the model and which is the staging version. Also specifying in which port you will serve this model. And to make it releasable and simple, I integrate the served model in the web page using Flask for the backend part. So here we specify the host, which is localhost. I specify the port, which is the port for the model serving 501, and then predict the data from this REST API. This is the final web page. So I integrated the MLflow with this web page. So the model with the deployed automatically from the registered model, which is used car price prediction and the stage prediction. So let's test the final output. For example, let's pass the kilometer drive, and this is the final result. So as we see, the price is loaded with a success. Let's try, for example, change the year here and predict the price. So as we see, the price is predicted successful. So that's it for my project. I started by loading the data from Google, do some data preparation and preprocessing. After that, I integrate the MLflow part. So I start by the MLflow tracking to save the experiments, such as the model parameters, the model metrics, and the model itself. After that, I compare all the runs, and I choose the run that have the higher score, and I save the model for the run that have the higher score in model registry. After that, I transit the model from the non stage to the prediction stage, do some prediction locally. After that, I serve this model to the REST API, and finally, I integrate the REST API serving in the web page, and this is the final output. By completing this project, I discovered the powerful of MLflow platform. We can easily save our experiments, compare our models, save the model that have the higher performance. So that's it for my this project. I hope that the idea is clear for you and you like this work, and thank you for your attention.